This is section 2.1. Well, let me get you the problems for that. Okay, so we have 17 to 71 on page 192. Okay, sorry, there's a shadow in the middle there I can't get rid of. There's 17, 19. So it's 19 is f of -3, f of 3, f of 0, and f of a half. Need that. And there's 31. Kind of see 33. That's x squared plus 2x for 33. If x is less than or equal to 1, x. If -1 is less than x, less than or equal to 1. -1 if x is greater than 1. Some more over here. Domain range. Or domain. It's hard for me to get you those. Oh, there we go. 67, 69, and we had to go up to 71. So I think you can catch all those. Okay. Okay, so problem 19, f of x equals x squared minus 6. Asking for f of -3, put -3 here, -3 squared minus 6, 9 minus 6 is 3. F of a half, 1/2 squared minus 6, 1/2 squared is 1/4, 1/4 minus 6 is -5 3/4. 25, g of x is 1 minus x over 1 plus x. G of -1, if I plug in -1, I get a 0 in the denominator, so that's undefined. G of a, simply 1 minus a over 1 plus a. G of a minus 1, right here, pretend you erase it, put a minus 1, erase this, put a minus 1. So that's 1 minus a plus 1 over 1 plus a minus 1, 2 minus a over a. G of x squared minus 1, put x squared minus 1 in place of x in parentheses, here and here. Looks like this. 1 minus parentheses x squared minus 1 divided by 1 plus x squared minus 1. 1 minus a minus 1 is 2. 2 minus x squared over x squared. 29. F of x is 2 times absolute value of x minus 1. F of -2. 2 times the absolute value of -2 minus 1. -2 minus 1 is -3, whose absolute value is 3. 2 times 3 is 6. F of x plus 1, put x plus 1 in parentheses right there. 2 times absolute value of x plus 1 minus 1. 1's cancel out, 2 times absolute value of x. F of x squared plus 2, put x squared plus 2 right there. 2 times absolute value of x squared plus 2 minus 1. 2 times absolute value of x squared plus 1. In this case, x squared plus 1 is always a positive quantity, so you drop the bars. 2 times x squared plus 1. 33, the piecewise defined function. F of x is x squared plus 2x. If x is less than or equal to 1, x, if x is between -1 and 1, not counting -1, but including 1, and -1 if x is greater than 1. Okay, x squared plus 2x, I know that's parabolic. I plug in -1. Let's see, if you plug in -1, -1 squared is 1, plus 2 times -1 is -2, so it's -1. And I know it's parabolic, I'll just curve it like that. Okay, then x between -1 and 1. If I plug in -1, I actually get -1, so it's continuous right there. Goes like that. Excuse me. Then for x greater than 1, constant function -1, y equals -1 is a horizontal line. I do not count 1, so it's an open circle here, and goes like that. 35, f of x is x squared plus 1, f of x plus 2. Replace this x with parentheses x plus 2 squared. That's x squared plus 4x plus 4 plus 1, x squared plus 4x plus 5. F of x plus f of 2, well, f of x is the original, x squared plus 1. F of 2, put 2 in here, I get 5, so x squared plus 6. I did behind the problem showing you that these two are not equal. In case you think that f distributes, it does not. These two are different. 41, g of t is 1 minus t squared. From negative 2 to 5, what's the net change? The net change is g of 5 minus g of negative 2. So g of 5 is 1 minus 5 squared, minus g of negative 2 is 1 minus negative 2 squared. 1 minus 25 minus 1 minus 4. Negative 24 minus a negative 3, negative 21. 45, f of x is 5. F of a plus h minus f of a all over h. Well, no matter what's behind my pen there, the answer is 5. So that's 5. That's also 5 divided by h. 0 divided by h is 0. So that was a little bit too trivial. Much harder is f of x equals x over x plus 1. And they're asking for f of a plus h minus f of a all over h. Okay, so f of a plus h, well, replace x with a plus h. So a plus h over a plus h plus 1 minus f of a, put a right there and there, a over a plus 1, all divided by h. This looks funny. Well, if I divide by h, it's the same as multiplying by 1 over h. So 1 over h. Okay, and right now I haven't done anything. That's the same as that. That's the same as that. But I need a common denominator. So multiply this side by a plus 1 over a plus 1. This one needs a plus h plus 1 over a plus h plus 1. Okay, so the top, we'll leave the bottom alone. The top is a squared plus a plus ah plus 1. All of these are going to be minus a squared minus ah minus a. Cancel, cancel, cancel. I'm left with negative h, and that negative h will cancel that h. Okay, so the answer is negative 1. Should be a negative here, sorry. Negative 1 over a plus h plus 1, a plus 1. 53, f of x is 3x. X is going from negative 2 to 6. So f of negative 2 is negative 6. F of 6 is 18. It's a linear function. So for this function, the domain is bracket 2, 6. The range is negative 6, comma 18. 57, just ask for the domain. The bottom factors in x plus 1, x minus 1. This expression is defined everywhere unless I'm dividing by 0. I'll be dividing by 0 if x is negative 1 or positive 1. So the domain is all real numbers minus a set consisting of negative 1 and 1. 63, find a domain. If I have the square root of anything, the thing behind my finger is greater than or equal to 0. Okay, move over to 2x. 1 is greater than or equal to 2x, divide by 2. 1/2 is greater than or equal to x, or x is less than or equal to 1/2. So the domain is parenthesis negative infinity, comma 1/2 bracket. 67, fourth root. Same thing, I can only take the fourth root of non-negative quantities, positive or 0. So the thing behind my finger, x squared minus 6x greater than or equal to 0. Factor x times x minus 6 is greater than or equal to 0. My boundary numbers are 0 and 6. Closed circle, closed circle. If I plug in 0, I get 0 is greater than or equal to 0. And that's true. If I plug in 6, I get 6. Minus 6 is 0, and 0 is greater than or equal to 0. Those are both true. And test a point from here, here, and here. I plug in negative 1. Negative 1, that's a negative, that's a negative. Negative times a negative is positive. Positive greater than or equal to 0, that's true. Shade this region. Region 2, plug in 1. 1 times negative 5, positive times a negative is a negative. Is a negative greater than or equal to 0? No, that's false. So don't shade in region 2. Region 3, try 7. Positive, positive, positive times positive is positive. Positive greater than or equal to 0 is true. Shade region 3 in. So the domain is negative infinity, comma 0 bracket, union 6, comma infinity. All right, so these are some problems from section 2.1.